So yes, thank you. Good morning. I'd like to set the scene today on really how application architectures have evolved over the years. I'm sure you're aware, but if we look at our traditional enterprise data centers, those applications were usually very static, usually very siloed on individual devices. We knew exactly where our workloads were, and the amount of mobility, the amount of dynamism in that network was therefore very static. The advent of virtualization has meant that workloads have become very mobile, and necessarily the network along with that has had to become more agile to cope. That's only happening more so with the onset of also public clouds, along with on-site, on-premises private clouds, where a hybrid approach, your workloads aren't necessarily even in your data center, and they can change on a dynamic basis. So that's the needs of the application of the system. So as a network, how do we cope with that? Now, I work for a networking vendor, and traditionally, networking vendors love to solve problems with more complexity. This new protocol, this new standard, adding more and more complexity into the network. But really, that's not always the right solution. Really, I think what we need to be doing to address these problems, address the needs of the new demands, new workflows, is really just to simplify. Keep it simple. And this is what many of the large cloud players do. If we look at how some of the largest clouds, the cloud titans in the world build their networks, they're actually built on quite simple principles. And this is what we do with many of our largest customers. But these principles can be applied across the size of organizations, size of network estates. So you don't need to be a hyperscale provider to take note of these principles, right? And they're very simple principles. So to start off with, we're building pretty vanilla IP networks, right? We're using standard protocols. If we're running an IP network, we're using something we know and love. We know a protocol like BGP or OSPF to build these networks. There's no special new fabric technology in there requiring a new skill set, a new set of specialized hardware. We're using those standard technologies we know and love. The design is a very simple design, a very flat, scalable, two-tier design. And what this design gives you is excellent scalability such that we're building one flat, repeatable, elastic network, right? If we need to add more capacity, it's really simple because we can add more leaf switches. If we run out of capacity in the spine, we can merely add more spine switches. So it's an extremely scalable design, very repeatable design. And the interesting thing about this as well is a lot of the complexity that we built into networks in the 90s for things like device-level redundancy, so technologies like ISSU and chassis, such that we can do in-service software upgrade, dual supervisors. The technology to implement that is actually very complex on a software level of how do you take a single home device and upgrade that in service with no downtime and do it very reliably. That's actually quite a complex technical problem. Well, if we look at the simplicity of these cloud networks, we're actually using network level redundancy, where we don't need to build in ISSU because any device in our network can actually fail. And really, we don't care. We have extremely good network level failover. On top of that very resilient, very scalable design, there's then a rich set of APIs within that to allow for workflow automation and programmability. So from a design point of view, certainly at Arista, we believe with these simple set of 3-4 network designs, we can address the vast majority of the world's data centers needs. So keeping it extremely simple, keeping it extremely standards-based with these technologies like LACP, BGP, OSPF. We've been using these for years. Now, yes, there's probably one new term in the room to some of you, which is this term VXLAN. And yes, this is a new technology. But again, we're trying to keep it as simple as possible in terms of having a routing protocol we know and love for the scalable underlay, and then selectively using this as an overlay where necessary. So this is almost a solved problem in a way, which is how do you build a very resilient, very scalable cloud network? So we have this excellent network, but there then becomes another problem, which is one of automation. So you've probably heard a million IT-based presentations that talk about this, but the cost of network downtime, the cost of network outages is now measured in hundreds of thousands, if not millions of dollars, euros, zloty. And so if we can eliminate those outages, that can have a huge business impact. And often, through automation, we can actually fix that. Often these errors are introduced through human error, manual processes, doing things on a box-by-box level, whereas actually, if we can automate this on a network-wide level, we can reduce a lot of this. Right? And this is a statistic from Gartner, the research firm, that actually said 80% of IT activity, time, dollars, is actually just keeping the status quo, keeping the lights on. So if we're spending all of the majority of our investment in that, surely we want to reduce that expenditure somehow. And automation is really a really easy way to do that. Now, there's some easy wins and there's some less so easy wins, but really, if we can automate network provisioning, right? If workflows move around the network, if we can automate that, then we can have a significant OpEx reduction there. And then moving into more complex means of automation where we can actually do upgrades and proactive fault isolation and management in an automated way. Wouldn't that be really powerful? So automation is great. Let's just take a quick look at how different organizations might look to do automation. So I talked about the largest clouds in the world, the cloud titans as we call them here at Arista. And really the way the cloud titans do automation is a very customized process. It's a very do-it-yourself fashion where they have dedicated software development teams purely for network automation, right? And that's great, but we realize that's only really practical when you get to that hyperscale of cloud. So how do you take those principles of automation but do it in a much more easier way? Well, some of you and some of the more high-tech enterprise and service providers, what they're already doing is using existing frameworks that they can leverage to achieve that automation. So they might be using existing DevOps tools like Chef, Puppet. We saw Ansible yesterday morning. So in combination with those tools and a manner of scripts and API calls and pushing netconf to the devices and all manner of very, how shall I put it, customized means, we can actually achieve a lot of that automation. And that's great. I'm not knocking that. We actually have many customers who do exactly that. But really, when we get down to the traditional enterprise, the traditional service provider, that's still quite a complex effort, especially if your networking team does not have those skills for that level of DevOps scripting automation. And I think what really, if you want to bring those principles of network automation at that level, you really need a turnkey solution, right? You need something that's ready to go where you can do a lot of those principles of cloud automation straight out of the box and get the majority of those OpEx savings without the need for all this custom skill set that the larger players have. How are we doing this? Well, just to set the scene again, if we look at the software architecture on our devices at least, we have quite a scalable, very elegant software architecture where all of the state within the system is stored in a central database we call sysdb. And the benefit of that is really twofold. First benefit is really it's just an elegant software architecture for reliability and just a good quality design. But one kind of side part of that is it's very powerful in terms of programmability, synchronizing state, and therefore automation. So one of the first things we did many years ago is we selectively shared state between the databases on 2 switches to share MAC learning for MLAG. So if we can selectively share this state between 2 devices, why not go for a network-wide approach that can give us a lot of the power that the cloud titans are doing with their in-house software skills? And that's really what I'd like to announce today, which is our Cloud Vision offering to do exactly that. So we're providing a network-wide set of services, workflow tools, and so on to provide that turnkey automation. So gone are those days of spending hours hacking scripts together to do what you want. A lot of that can actually be now out of the box in a turnkey, ready-to-use way. How does this look in practice? Well, there's actually two parts to it. So what we're calling the CloudVision Exchange, CVX, and CloudVision Portal, CVP. CloudVision Exchange provides a network-wide means of synchronizing state, so we can get network-wide views of things like tables and so on, and then exposing a wide set of APIs to all manner of overlay controllers and orchestration tools. So I think the key point here is really why we're doing this, and this is for all of those principles of workflow and workload automation, right? We're not making a controller, but we provide a wide means of integrating with third-party controllers if you wish. So that's this CloudVision Exchange, and then sitting off on top of that is what we call the CloudVision Portal, CVP, which provides all those workflow services, and you'll see that shortly. So we're synchronizing state using open APIs between the devices and CVX, and then presenting that northbound to our own tool, CVP, and also a wide range of third-party systems. So looking at CloudVision Exchange, it's really a network-wide database. So it's taking that SysDB architecture that we've had on a single box level and a two box level to actually a network-wide level. So we can do quite powerful things with that, like providing a single point of integration for controllers, rather than a very complex system of connecting a controller on a box-by-box basis. And we can also abstract that physical network to expose. It opens up a lot more power as well in terms of network-wide data collection. So you can get that very holistic view of the state of your network, rather than having to go on a much finer grain level, box by box. So if you were looking to integrate with the likes of controllers, network services, cloud orchestration tools, this is a really simple way of doing this. So it's exposing that as a single point, and also for integration with our own services, which I'll come on to shortly. Sitting up and underneath that is a network layer with a GUI and a command line to allow you to access that information in the easiest and simplest way. So talking about controllers, let's take a standard like OVSDB, which if you're not familiar with it, is a standard for originally for programming vSwitches, but essentially it's a means of allowing a controller to provision tenant networks on both a virtual and a physical device. So I suppose the traditional approach to doing this is you do it on a box-by-box basis, which is actually quite complex, does not scale so well, and so on. So with CloudVision, what we can do is we can have a single OVSDB connection to a controller, and then that state can be synchronized across the network. And this is really just good API design, which is, with a good API, you want to abstract the implementation details of the underlying system to expose to that interface. And that's what we're doing here. To use an example, if you're configuring pairs of devices where the servers are dual homed and you want to provision a server on both devices, that's exposed directly and abstracted to that northbound interface. So the overlay controller does not need to know that implementation detail. Why should it? So with that as a very solid foundation for synchronizing that network state and exposing it to controllers, we can then build some cool stuff on top with the portal. So a wide range of things, single pane of glass visibility into the network for things like provisioning, upgrades, rollback, change management, overlay visibility, and I'll go into each one in detail. So this single pane of glass really is a means of doing all of these workflow services in a single point. First element is, again, taking this box-by-box approach through to that network-wide view with service dashboards in a single place, consolidating, and really just using modern technology to do this as well. So gone are those days of having multiple legacy tools for each element. It's actually pulling it together. And the first element I think is quite cool is provisioning. So rather than show you it on a slide, I'd like to actually hop into a brief demo and show you it for real. So to log in, this is the view of our CloudVision portal, which I'm just refreshing to check my internet connection is still there. And you'll see there's a wide range of services you can actually access from this portal. On the right-hand side, we've actually got a news feed, which we're pulling from our own data. That gives you updates on software versioning, security fixes, and so on. So to demo the provisioning system, what this is really doing is allowing you to take a network-wide view of config provisioning, device provisioning, where we can actually abstract the devices rather than on a box-by-box basis onto quite an abstract basis based on containers. So I mentioned these leaf and spine designs. You can place all your leaf switches into a single container and then manage it as a single container. So if I want consistent configuration across all those devices, I can apply it with one change. I'm not going on a box-by-box basis, introducing human error and so forth. So to show you a simple example, I'm going to make a change right now. And we've actually broken down the config into configlets. So we're still using that same command line syntax for configuration you know and love, but breaking it down into building blocks where we can apply it on a container basis. So I'm going to build a new configuration configlet here. I'm just going to call alias PLNOG. Very, very simple change here. And we can set aliases on our command line. So I can say every time I type the command PLNOG, I actually want to type show donkeys, let's say. This is a real command on our switch if you don't believe me. So if I log into an Arista switch, this is a little Easter egg where we can actually print a donkey. So that's a little tip for you there. So I'm going to create this alias. We can then log into a switch to validate that configuration. So if I make a typo, a human error, I'll be alerted at that point instantly. So I'm going to save that. And I need to give it a proper name. So I'm saving that configuration. And that's one of the many building blocks I have in my toolbox. I can then take that toolbox and apply it to a range of switches in one go. So if I want to update, in this case it's a very simple change, but it could be updating my security policy, for example, to get that consistent configuration. I can do that on every device in my network if I wish. In this case, I'm going to do it on just the leaf switches because that's only the boxes I will use them on. So if I go to the existing configlets, you can see its existing config has been made up of these configlets, these building blocks. So all I'm going to do is add a new building block, which is my PLNOG alias, and click Update. And what that will do is actually stage that configuration. So you now see this T above the two leaf switches, and that means there's a pending task for that leaf switch. And that pending task is to configure that alias. So the task has not been applied yet. You can wait, do it in a change window, and so on. So that goes into tasks, which we can then integrate with the likes of ServiceNow, so changes can be approved and so on. So if I go into those tasks and actually go to apply those tasks, CVP will actually connect to those devices and push that configuration accordingly. Once a change has been completed, it will be marked as completed. And the nice thing as well, we have a nice, beautiful audit trail of every change that happened in the network via CVP. So you can see with this exact task, we can see the full detail of what configuration was pushed and whether it succeeded, and that full rich set of detail and reporting, which is very useful not only for troubleshooting and debugging, but also for compliance reasons as well. So the provisioning element is only one part of it, but it's a very powerful, it's a very simple way of doing network-wide provisioning. Sitting on top of that, we're also having some other services such as change management, which is really like, how do you automate a maintenance? If I need to upgrade the software version on all of my 50 leaf switches, that's traditionally quite a complex task, so why don't we automate that? So we can not only do it on a device-by-device basis in an automated fashion, but we've also got things like system snapshot, where, forgive me, you cannot see the detail here, but we can actually compare the tables on the devices, how many routes we have, how many MAC addresses we have, before and after an upgrade, right? And then, if we wish, either allow that within a certain success criteria, or expose that to a real human network operator to say, hang on, I'm missing 4 routes, this change maybe didn't go so well. If the change didn't go so well, this then opens the possibility for network-wide rollback. I think one of the few cool new networking features in the last 15 years that actually made your job easier was something like the rollback command on a certain other vendor's operating system, where you can commit a change. If that change did not go well, you can roll it back. Great idea. So why not do this on a network-wide basis? If you're doing a network-wide change, right, so you're getting that benefit of automation and it does go wrong, you can instantly restore the network in a very short space of time. So that can be very powerful as well, we think. So wide range of automated workflow services, and then they're tying in with our many third-party partners as well. So there's the overlay controllers like VMware NSX and Nuage networks via OVSDB. We're providing that very elegant single point of integration, and then a wide range of other partners as well, like security partners and so on. So in summary, what we're doing is we're providing that out-of-the-box, very turnkey means of automating your network without that complex overhead of the very manual, custom, do-it-yourself approach to automation. So reducing that operational expenditure and really treating it as a network-wide means of doing that. So, thank you very much. Thank you for listening. Any questions?